In this video, we will go over how to introduce custom materials into the AutoLion-3D materials database. In order to successfully implement a new material, the following information about the given material is required: molecular weight, density, first charge capacity, first discharge capacity, and the particle diameter. You also need the OCP curve of the material, the exchange current density, the entropic heat generation, and the diffusivity of the material in the form of either a constant or a function. In this video, we will implement a new LFP material based on the values provided in a reference paper which models a commercial LFP graphite cell. To get started, we'll open the materials database editor within the AutoLion GUI, where we see a complete list of the existing materials inside the database. We'll click Add a Material and proceed by entering in the properties of the new material. I'll enter the name here and fill in the rest of the parameters. The Umax input you see here is essentially the starting point on the OCP curve, which corresponds to a fully charged cell. And lastly, we'll define whether or not this is a positive or negative active material. Once this is done, we can click Save Update to officially modify the database, and if we come down to the positive active material selection, we can see that LFP2 is now added to the list. The next important thing to do is modify the UDF files to account for the new material. If you remember, any new custom material requires an OCP curve, diffusion coefficient, entropic heat generation, and exchange current density values, all of which are input through the UDF functionality. We'll start by first modifying the OCP curve. In this example, we'll use an empirical function for LFP as described in the reference. All we need to do is enter the function as is described in the paper. You'll see that we're including a variable for stoichiometry here using the symbol provided in the preamble to the UDF file. Once this is done, we can move on to inputting the diffusivity, exchange current densities, and entropic heat generation values. For these, we'll just use constant values taken from the same reference, or in the case of the entropic heat, we'll just leave it at 0. Once you've saved your files, simply continue setting up the rest of your case as you would normally. You can switch the OCP, diffusivity, entropic heat terms, and exchange current density parameters to the UDF, but even if it's set to database, the software will automatically read in the UDFs for the custom material. And that should be it. When the software is launched, the UDFs will automatically be compiled and included in the simulation. This process can be repeated for any desired material for either the positive or negative electrode, as long as all of the required information is available. Thanks for watching.